Hello, everybody. My name is Eric Normand. How are you doing today? I'm about to share my slides. Okay, so I'm going to be talking about functional programming. I like to start out with a question. So just in your mind, maybe even in the chat, you can drop in an answer to this question. What is functional programming? So my talk is called A Fresh Look at Functional Programming. I want to thank the organizers for allowing me this opportunity to present today. Thank you. I know how much work it is to put on a conference, so thank you so much for doing that. So my talk is called A Fresh Look at Functional Programming, but as I was finalizing these slides, I thought it might be better to call it A Fresh Look with Functional Programming. Meaning a fresh look at your code, at your way of programming using a new paradigm. Instead of focusing on functional programming as this abstract thing, we should be focusing on your real code and your real work as a programmer, but just with a new lens. So today I hope you come away with this new perspective on programming, a few new skills that will help you write better software. And of course, this is a 5-minute talk. I can't give the whole field of functional programming, but maybe this will inspire you to go seek out some more information. All right, a little story. Back in 2013, my friends and I started a meetup, a local meetup about functional programming. And every time, at least for the first year, it would just devolve into a discussion of some very basic questions that would just come up time and time again. What is functional programming? Why should I care? How will functional programming help me? And we would just hash these out over and over with new attendees who were just trying it out. Some people were very interested in functional programming. Some people weren't. Should I rewrite everything in FP? Is this an all or nothing thing? Can I do it in JavaScript? Like, why should I change languages? And I don't know FP. Can I learn it with JavaScript, or do I need to really try something else? And I had no way, nothing I could recommend to people, because the more we talked about it, the more difficult it seemed to be to actually find some resources that could actually answer the questions. And so I decided to make that resource. I wrote a book. It's called Grokking Simplicity. It is the book that I wanted to recommend to all the people who came and hadn't really known much about functional programming before. There's a link here and a coupon code. It'll give you 35% off anything at Manning. It's published by Manning Publications. I'm going to drop a poll in the chat right now. I'd like to know what your familiarity with functional programming is. So I'm going to keep talking, but you can go answer that poll, please. That would be very helpful. Okay. I'm curious, and I think other people would like to know where they fit, like if they're in the majority, minority, etc. All right, so in this book, I had to kind of answer this question: what is functional programming? And come at it from, I decided to come at it from a very pragmatic point of view, that functional programming is a set of skills. So basically, if you draw this Venn diagram, the circle on the left is all the things that non-functional programmers do. And then the circle on the right is the things that functional programmers do. There's a lot of overlap. There's a lot of stuff in common. We all have functions, we name them, we have variables, data, that kind of stuff. But then there are things that only or mostly functional programmers do, that maybe some people in the non-FP group does, but they know that they're borrowing it from functional programming. And so this blue section here is what I decided to focus on in my book, Grokking Simplicity. And so I had to organize this stuff to, put it into some table of contents in a linear order. So I kind of arranged the skills that I wanted to teach into 2 levels. So there's the first level, which is all about distinguishing actions, calculations, and data. This is a skill you can apply regardless of what language you use, regardless of the paradigm that you're using currently. And we're going to go into this. We're going to go into both of these points. But this can help you improve reuse, testing, and maintainability. And then the second level we'll also go into is creating and using first-class abstractions, something that functional programmers, I find in my experience, do much more than non-functional programmers. And these let you solve more complex problems and control timing problems, which we'll get into. Okay, I'm going to drop another poll before we get started with this. This one is about your familiarity. Oh, wait, sorry, with your impression of functional programming. So like, if you've been exposed to functional programming before in any way, even if you just heard of it, drop in your answers here. All right. All right, so we're going to go into part one. This is level one, distinguishing actions, calculations, and data. What are they? We're going to talk about something called the spreading rule, and we're going to look at a refactoring that functional programmers do all the time that will be useful, in your current code base. All right, distinguishing actions, calculations, and data. Okay, so imagine we had some little snippets of code that come from some random code base. We see some JSON up at the top. It's all in JavaScript just to make it kind of universal. We see this function called send email. There's a function called sum. It's a function called save user database DB, string length, get current time, and then some more data at the bottom, an array. Now I've put stars next to 3 of these because these functions are different from the others in a very important way. I can call some numbers as many times as I want, and I'm not really going to affect the outside world. But if I send an email, if I send it twice, it's much different from sending it one time. Likewise, saving a user to the database, it really depends if I call it, right? It's going to have an effect if I call it, and it's going to not happen if I don't. Likewise, for get current time, every time I call it, it's going to be a different time returned. So in functional programming, we draw a line. We move all those starred functions above the line. And in my book and in this talk, I'm going to call them actions. We're going to define them in a minute. Okay, and then everything under that line is just the rest of the stuff. But you notice there is kind of a difference between functions and some data, right? Functions run, you can execute them, whereas the data is kind of just there, it's inert. So we're going to draw another line. And so we're now dividing it into 3 different categories of code. We got actions, calculations, and data. Okay, calculations are computations from inputs to outputs, and data is recorded facts about events. Okay, let's go through and define them a little bit more concretely here. So these are dictionary definitions that I looked up that I thought captured the idea very well. So actions are the process of doing something typically to achieve an aim. If you are familiar with FP jargon, these are known as impure functions, sometimes effects or side effects. And there's a rule of thumb for identifying them if it depends on when you run them or how many times you run them. So when you run them is like the timing, is the order that you run them. If you run this one before that one, etc. So that's the order. And then how many times you run them, that's the repetition. Calculations quickly are just computations from inputs to outputs. You'll get the same answer every time if you pass it the same arguments. They're not going to affect the outside world. What that means is that they are eternal and outside of time. So imagine something as eternal as the plus operator, right? No matter how many times you call it or when you call it or what machine you call it on, you're going to get the same answer. It's just addition. It's timeless. It's not going to change. And in FP jargon, we call these pure functions or referentially transparent functions. You might have heard those terms before. I'm going to call them calculations in the talk. Okay. And last, we have data. Data is facts about events. You can use them as a basis for reasoning, discussion, or calculation, just to make it sound more like a real definition. I mean, this is a real definition. I did take this from the dictionary. Characteristics of data, inert. It's kind of self identical, right? It doesn't do anything. It just is what it is. It's serializable, but it requires interpretation. So you need some, person or a software to read it and make some assumptions about what it must mean. And that's what our software does, is it takes in data, for instance, a web request, and it interprets it. It says, oh, these are the headers, this is the body. And, then this body is, a request to create a user, for instance, and it makes all these interpretations of the data. All right, so functional programmers tend to write more calculations compared to actions. That is like a characteristic that everyone will agree with, that they try to write calculations when possible and actions when necessary. But and I think that that's pretty common knowledge. No one would disagree with this. But something that's a little more controversial that I have noticed that I don't think other people are talking about is that we pay functional programmers, that is, we pay much attention to actions than to calculations. Why? Because actions, because they depend on when they run, are much harder to deal with. That's a lot of bugs come from, timing issues, synchronous or asynchronous access of the same resource. And so we have to spend a lot more of our mental cycles, maybe even a lot more of our code dealing with actions. Okay, so people will say, oh, functional programming is all about programming with pure functions, with calculations, and not actions, not impure functions. But I find it's not the case. In practical, real world commercial software, we do write a lot of actions. We need to send that, but we are just careful with them. So we spend a lot more attention on them. All right. So that's actions, calculations, and data. You can go through your code and kind of figure out what's an action, what's a calculation, and data. And one of the things that will help you do that is the spreading rule. Oh, I forgot to say this. If you want to ask a question, drop it in the Q&A tab, and I'll answer them at the end. I think that's the best way to do it. Okay, so the spreading rule. This is like a little excerpt from my book, From Grokking Simplicity. Here's a programmer who has some code, and it basically it's an e-commerce platform, and they want to pay out all the affiliates. So they need to see this main function at the bottom. It runs a function called affiliate payout, and affiliate payout loops through all the affiliates and figures the payout. Figure payout looks at the number of sales, multiplies it times the commission. If it's over $100, then it's going to send the payout with the bank, right? All right, so that sending a payout is definitely an action, right? Like it depends on how many times you call it. If you call it 0 times, they're not going to get their money. If you call it 1 time, they're going to get their money. But if you do it twice, they're going to get too much money. So it really depends on how many times you call it. So it's definitely an action. So she highlights it and says, but look, I only have 1 action in my code. Well, she's not applying the spreading rule. So let's apply the spreading rule to this. So here's the code. We're going to start with that highlighted action. Now, the spreading rule says if you highlight an action inside of a function, that whole function becomes an action, because Now it depends. Did I call figure payout? How many times do I call figure payout, right? So that becomes an action. And so now you have to highlight all the places where you call that function, and it's called down in affiliate payout. And so then we apply the rule again, and it says, well, now that we have highlighted a line in affiliate payout, we have to highlight the whole function affiliate payout. And that means we also have to highlight where it is called. So in main, we highlight that. And then finally, because main calls it, it becomes an action. So eventually we realize, like, yes, you had that one action at the bottom, basically the top of the call stack, the last thing you call in the call stack. Everything below that has to be an action, right? Everything below that depends on when it is called and how many times it is called. So it's all actions. So a lot of times we maybe try to hide actions by burying them deeper and deeper, but it doesn't change anything. You still have actions, and everything that calls that stuff is still dependent on when it is called. And this is something that functional programmers do intuitively, that we distinguish in our code, and we can identify very quickly what is an action and what is not. All right, so what do you do with that? How does that help anything? Well, here's a refactoring that functional programmers apply all the time. It's called extracting calculations. So here we have a function called show total. It's going to loop through all the items. It's a global variable, notice, items. Okay, see items.length here in the for loop. It's not a local variable, so it must be global. And it loops through, sums up all the prices, and then sets the DOM inner HTML property to that total. Okay, so this is very common in like front-end development. You just set some text somewhere to be the total of the shopping cart. Now I'm going to highlight this stuff in red, that is actions. We're reading from a global variable. Something else could be writing to that, at different times. It's globally accessible, so we don't know. Like, if we call show total at different times, we could get different answers, right? Also, we're writing to the DOM. So the DOM it's having an effect on the user. But then the stuff in blue, this stuff is kind of, if we could somehow get rid of that red items, this is actually pretty calculation-y, right? This is something that is timeless, just like summing up all the stuff in the shopping cart. So we're going to extract that blue section out. So we have a function called sum total that takes items as an argument, and then it's going to just do that code, and then it's going to return the total. Okay, and then show total then just calls sum total. I'm sorry. So the argument to sum total should be red. Items should be red because that is reading from a global variable. But sum total itself is a calculation now. So we've taken this code that was part of an action. It was, it was doing a calculation, but it was inside of a function that was an action, and we've extracted it out. And we're still left with the action. The show total is still an action, but we have this other code called sum total that is a calculation. Now, what have we done? We've actually analyzed this for implicit inputs and implicit outputs. Reading from a global variable, that's an input that is implicit in our code. It's implicit because the explicit inputs to a function are its arguments. Likewise, we have an implicit output. We're writing to the DOM. And the explicit outputs of a function are its return value. So we've basically turned the implicit inputs into arguments and the implicit outputs into a return value. And we still have to read from that global variable unless we refactor the whole thing, right? But just for this one function, we've managed to just kind of piecewise improve it by removing this this one calculation. Okay, so this is just a summary of what we did. We replaced implicit inputs with arguments, and we replaced implicit outputs with return values. So now I want to talk about reuse testing and maintenance in this context of what we just did. So which is easier to reuse, calculations or actions? So I'm just going to switch back to slides. I'm improvising now. Look at this sum total. Is that easier to reuse than what we had before, which was show total, where the for loop was inside show total? And I would argue yes, that sum total is much easier to reuse. When you're talking about reuse, you're talking about reuse across departments in different runtimes. So you're talking about maybe I'm reusing it in Node on the server or JavaScript in the browser. You got different contexts. Maybe I'm calculating the total to display to the user in one context, but I'm also calculating it to calculate the VAT in another context. Also, we have different assumptions about like what is going to be in that global variable at different times. And in the case of making it an explicit input, we don't have to have that assumption anymore. And then different times, of course, you're going to be running it in your development machine, on the build server, and production. There's all sorts of different places. So I would argue that calculations are just inherently easier to reuse. There's much less setup you have to do. You don't have to set up that global variable, and you don't have to set up a mock DOM in order to reuse it. Likewise, testing. You're going to be testing in different places on your local development machine, on the build server. When you test something, you want to run it multiple times. So actions, because they depend on how many times you call it, are inherently harder to test just by definition. You want to test something thousands of times, right? Every time you run your test, you might run it 100 times with different scenarios. And then you're running your tests all the time on your local server. Every time you do a deploy on the build server, these things are getting run all the time. And so it's just inherently easier to test a calculation. You've also got different run times, and across time, these test functions, the tests could last for years, and just having something timeless like a calculation is just inherently easier. Finally, maintenance, basically being able to respond to changing context. Maybe you're reusing this code for different purposes under different assumptions. Your requirements are changing. All this stuff, you're learning more about your domain. All this stuff makes calculations easier to use because they are timeless. Okay, so this is part 1 of the book. This is a small part of what we get into in part 1, which is all about working with actions, calculations, and data. And it's sort of like, the idea is it's sort of like a doorway. Once you understand this idea, it opens up a whole bunch of refactorings and new ways of working with your software. I'm not going to read all these. You can read them. But this is just a small part of what we deal with in part 1. All right. Again, the 2 levels. Now we're getting on to number 2, creating and using first-class functions. We're going to talk about 3 things, 3 skills in creating and using first-class functions. There's 2 refactorings. One is express implicit argument, and the other is replace body with callback. And we're going to do some work with timing issues and controlling the repetition of actions. Okay, it's very exciting. All right, first refactoring, express implicit argument. All right, so refactorings go with code smells, right? You have a smell, and so you want to fix it. So what is the smell? It's called implicit argument in function name. Let's say in my code I have these 3 functions: set price by name, set quantity by name, and set discount by name. Set price by name, you see it gets the item out of the cart by name, and then it sets the price. You see it passes in the string price on that object, and then it adds that item back to the cart. So this is a very common functional pattern where you're doing copy on write. We talk about that in part 1. Copy on write just means you make a copy before you modify it. You only modify the copy, and then when you return it, you don't modify it anymore. And that's a way of implementing immutability. And then set quantity by name is very similar, except instead of passing the string price to object set, we pass the string quantity. And we see that on the second line. And then set discount by name looks the same, except it's passing the string discount. So there's a lot of repeated code here. And the smell is that we are actually including that string basically in the name of the function. So price, when we're the function where we pass the string price has price in the name, and then the function where we pass quantity has quantity in the name. So this is like an implicit argument. Instead of passing the argument of what field we want to modify, we're duplicating the function, but using the name of the function as a way of indicating which field it's going to modify. Now I have a poll here. I'm going to publish it also. Okay, this is just asking if you've seen this before, because I'm always surprised. Sometimes I feel like I might have had a unique experience with this where code bases explode because they need to write this same function over and over. So if you've seen it, please answer the poll. If you haven't seen it, that's fine. Answer it too. Answer a negative. Okay, so here's what we're going to do. This is set price by name at the top. I've highlighted all the places where we're using the word price, right? And we're just going to replace price by field, a generic. We're taking it up one level of abstraction. We don't know what field we're setting. We're just going to call it field. And so we're adding an argument called field. And instead of hard coding the string price, that field is what gets passed to object set. And then of course we have to call it value now, because it's that next level of abstraction. We don't know what kind of value it is. So it's a generic term. And this lets us replace all of those other functions by just passing in the string as we call it, right? Now we haven't changed any information in the code. We've just moved it from inside the name of the function to the to an argument, right? So it hasn't changed any information, and so it's much better. And this allows us to stop writing the same function over and over, and just have this first class field reference. And JavaScript is nice because it lets us do this. If you were using another language, let's say Java, you could use an enum instead of a string. It'd be much better because you get type safety and stuff like that. But in JavaScript, we're running wild, blind anyway. This doesn't really make it less secure. And in fact, now you can even add something to set field by name that checks that the field is, one of the valid ones that you accept. And then, throw something at runtime. Or you could use TypeScript and it could check it for you. Okay. I am going to check the results of the poll because I'm really curious. Show results. Oh, okay. 69% out of 45 votes have seen this smell before. I'm curious whether you had a fix for it, but this is something that functional programmers often do, is they take something that's kind of implicit and make it first class so that you can use your whole program to operate on it. Okay, we're going to move on to another refactoring. It's called replace body with callback. This is all about syntactic abstraction. All right, so the smell that this course is syntactic boilerplate. Here on the slide, we have two different for loops, but they're essentially, the for loop part is the same, but the body is different. And so how do you abstract this? How do you, the real problem is, like, typically you would say, if you're going to take a function and break it in two, right? And say, like, well, this is too many steps in one function. Let's make it, let's make subroutines to do half of it and then the other half. You would take the first 3 lines and put them in a function, and then the last 3 lines and put them in a function. And then now you call those 2 functions from the bigger function. But you can't do that with a for loop. Why? Because the curly brace at the top has to match syntactically the curly brace at the bottom. There's no way to separate them syntactically. So how do you make it so that the thing inside the curly braces is what varies, and the thing on the outside, the top and the bottom of the for loop, are the same? So we use this refactoring. So it's called replace body with callback. You have to first identify the before and after code, and then the body is going to be in the middle, like a sandwich. So we're going to have the for loop part, all the, iteration through the indexes of an array. That stuff is the same in both for loops. Likewise, the closing brace is the same. What's different is what happens inside of the for loop. So that's what's in green. That's the body. And so we're going to write this function called for each. You might be familiar with it because it does exist already in JavaScript, but we're writing it again just to learn how it works. It takes the array and a function, and that function is going to be the body. That's why it's green, right? So all the red stuff gets put into there, and then the function is going to take, the red stuff is going to iterate through the indexes. Oh, it should be is.length. Sorry about that. But it's going to take that ith element of the array and pass it to the function, right? And that's our body. And what this allows us to do is, you see on the left we have the before, and on the right we have the after, where we call for each with foods, and we pass in a function that takes a single food from that array and then cooks it and eats it. Likewise, we have the for each, takes the dishes and is going to wash, dry, and put away each dish. So this is a refactoring that we do a lot. You can do it with all sorts of syntax in your code. For instance, try catch. The try and the catch are very syntactically, you have to repeat them all the time, but you could wrap, you can make a function that takes a function. So this becomes a higher order function that does the body of the try. And then you could even have one that does the body of the catch, right? And it'll handle the error. So this is a way of like not having to write for loops anymore. There's different for loops. This is just one variety where you're like iterating straight through an array and not returning anything, not building any new value up. You're actually taking actions like cook and eat. But you could, for instance, write map, which builds up a new array from by applying a function to the individual elements of an array. So there's all sorts of interesting functional tools that you can build with this. Okay, we're going to move on. Last thing, we have this problem. Actions depend on how many times they are called. Sorry, I didn't put times. Actions depend on how many times they're called, right? So you have an action. Let's say it sends a welcome email. So someone fills out a form on your site and they need to get a welcome email. And so you call this function and it sends the email. But there's a warning in the comments, like only call this once. We don't want to send 2 welcome emails, or, whatever else could happen if you like double click on the button or whatever else. We want to avoid that completely. And this warning is trying to say, like, whatever you do, don't do that. But it can get out of control. We would rather have our code do that control for us. So what's the solution? We can adapt this function so that it only runs once. So we create this little function. It's a higher order function. It takes a function f. It's very generic. And this is very common in functional programming, where we go up maybe a level of abstraction higher than I see people from other paradigms do, where it, it doesn't, it's like, what does f do? Like whatever you want, right? It's just a generic function. All right. So it creates this local variable called hasRun, starts off as false. Then once only returns a function that checks if hasRun is false. If it's false, it's going to set hasRun to true, and then it's going to call f and return its value, right? So this way, the second time you call this function that gets returned, it's not going to run f. The first time it will run f, but any subsequent time it won't. You can verify that that's the case. So this very simple function here, once only, is a very generic way of making sure that a function will only get called once. And we use it down at the bottom. So we do a send welcome email. We a new variable. So instead of defining the function, with the function keyword and a variable name, we're just going to assign it to a var. And we're going to pass a function to once only, same function we had before. It's going to send the email. So now you can call this function send welcome email as many times as you want. You can call it in a for loop if you need to, but it's only going to execute the email.send one time. This goes to a deeper issue that functional programmers focus on, is that actions need to be controlled. I mean, we sequence our actions, and there's an implicit order that things will run that our language defines, but that's often not the order or the kinds of repetition that we need in our domain. So we have to adapt the existing order that the language gives us to the domain and the order that we want it to run in. It's not just order, it's also repetition. So here's some examples of things you can build that are common ways of controlling repetition. So call it most once. That's what we just saw. So you can call it 0 times, call it 1 time, but then the second time has no effect. It's like pressing an elevator button, right? The second press does not change what's going on. You can also do call it most n times if that's what you want to try. Also, you could make it like multiple calls in quick succession this is hard to say, but the last one is what happens, right? So like, let's say you're adding stuff to your cart really quickly. You're just pressing add. You want the last call to calculating the total to be the one that shows up, right? So they might be asynchronous. They come back in different orders, but you want the last one to have an effect. You don't even need to calculate all the other ones. You can skip them because it's the last calculation to total that will show up in the cart. Okay, finally, ordering. This is when it's called, calling before or after some other action. For instance, if you're writing to a global variable before someone reads it or after someone reads it, it could have a very different effect on what goes on. So some common ways of controlling ordering, one action at a time. So you could have 2 actions happening at the same time that conflict because they share a resource. They're both trying to write to a JSON array at the same time. They're going to step on each other's toes, and you want to make sure that only one happens at a time. So, but maybe you don't care what order they happen in, but you don't want them to happen at the same time. You could have it so that one action doesn't start until others finish, right? So you have like 5 things that need to happen before you can finalize it, but those things are happening asynchronously. So you need to kind of wait until all 5 are done. This is common in something like promise.all. And then you could have it that the effects happen in the same order as the causes. For example, the cause could be adding items to your cart, and the effect is that gets sent to the server or that it calculates the tax or the shipping or whatever. If they happen in different orders, then the shipping is going to, the shipping is calculated based on like the second one you added, but then you've added 4 more since then. It's like it messes everything up. You want the cause and the effect to have the same order. So functional programmers, it's something that we focus a lot on, is we explicitly manage the timing, the repetition and ordering of actions. We basically create a new model of time that better suits our domain from what is given to us by the language. All right, there's much more. I've just gone through a few of the simple ones that I could present in a short time. In my book, there's, I don't know, 200 pages of this kind of stuff. All right, the organizers have asked me to give some thanks. They want to thank all of you, the attendees, and the other speakers, and the partners. So I'll talk about them for a moment. So there's Allegro.pl, which is the gold sponsor. They are the most popular shopping platform in Poland. There are 20 million customers every month, and 80% of internet users in Poland use that every month, which is that's pretty crazy. Now the silver sponsor is called Neoflex. They do custom software development for digital business transformation. There are 3 bronze sponsors. Metasite, they design and engineer bespoke digital finance platforms. So if you need like finance application for your company, they can do that for you. Telesoftis is consulting and product engineering, and they do a complete software stack. And Voltus IT, they are intelligent automotive diagnostics. They help you understand and customize your car. Thank you to the sponsors, because you make this possible. Conferences are very hard to run without sponsors. Please, also another message, rate the sessions that you've attended today. It's very helpful. As a speaker, I know that it really helps know how I did. So please do that. And then, of course, share on social media, feed the beast, let this rip and run wild. A little bit about me, where to find me. My book is called Grokking Simplicity. I've got a blog at lispcast.com. I got a podcast. I'll let you read it. And well, I want to say thank you. Manning has been kind enough to provide 5 codes for free e-copies. So if you act quickly, you can take one of these codes here on the right-hand side, and as you check out in your shopping cart, you can get that. Okay, I'm going to look in the Q&A. See what's oh, no questions. Okay, so if I'm going to switch back to these codes so you can see them. If you have any questions, please drop them in the Q&A. Got about a minute left, and I'll be monitoring that. Checking out the polls too. Very interesting. Looks like 32% have read some blog posts about it. That's the biggest one. 26% use functional programming every day. Huh. That's cool. Looks like 80% chose the impression of functional programming that it's somewhat useful, but no silver bullet. That's the reasonable choice. Maybe I should have phrased it differently. And then we have 71% have seen the implicit argument in function name smell. Okay, there's no questions. I'm going to end it here. See you later.